Our next example, LHA7, is for a fiber laser. This is the last example we'll do for an industrial style laser. Now, this laser is 1.55 microns, continuous wave. It's 200 milliwatts or 0.2 watts. ANSI default exposure duration is 10 seconds. We have some beam information here, but this would be as if we collimated the beam. In other words, we came out of the fiber into a lens that collimates the beam into something that gives us a waist of 2 millimeters and a divergence of 1 millimeter. Under this type of intrabeam exposure, we'd have a worst case OD of 1.318. If our observer range is at 0, we'll see they almost match. This wavelength range has a limiting aperture of 3.5 millimeters. So we have almost, with a 2 millimeter beam diameter, almost 100% of the beam, 99.8% of the beam is passing. We have an NOHD of 22.21 meters. Skin MPE, ocular MPE are the same, so yep, the nominal skin hazard distance equals the nominal ocular hazard distance. Let's take a look down here at the fiber optic where we have single mode. This is a 9 micron mode field diameter. Mode field diameter is the way we specify the output diameter of the output beam of a single mode fiber. Okay, is in mode field diameter. If you look in Appendix B in the standard, B2 symbols, and you look at the last symbol, which is omega naught, looks like a W subscript 0, but it's really a Greek letter, and it's omega naught, which stands for the mode field diameter. It tells you that the beam waist at the 1 over E squared points are similar to the mode field diameter. So we look at the mode field diameter as being the beam waist at the 1 over E squared points. Okay. Let's hold on to that piece of information. We'll finish this out. The observer range is 1/4 of a meter. Well, we have an NOHD of 0.1, so if we're 1/4 of a meter away, we wouldn't expect to have an OD at the observer range. Right. So let's set this at half the NOHD. Okay. And we have about 0.6 OD for the observer range. Something we want to do, and this is again one of these software checks, is if the mode field diameter is very similar to or comparable to the 1 over E squared beam waist, and a single mode fiber outputs a single mode, which makes it very close to a theoretically perfect beam, or an M squared of 1, we should be able to model this in the intrabeam. So for a beam diameter, 9 micron, that would be 0.009 millimeters. And then we put a 1 in for M squared. Okay. Let's put our observer range at 0.05 and let's compare. And sure enough, the NOHD, OD at observer range, OD at observer range match, so you can really model fiber outputs using the intrabeam. And again, page 118, the last symbol in the list will verify the information about the mode field diameter being comparable to the beam waist at the 1 over E squared points. Okay? All right, so that's how you input a single mode fiber. And if there's anything else about, I know what I wanted to do. In that last example, I really didn't go over the spectral reflectivity or viewing angle change that was on the slide. What I'd like for you to do is go back, use the software, and see if you can verify that information on that particular example. All right. What you should see is, of course, as the reflectivity goes down, the point source NHC will go down. As you change the viewing angle from 0 to some larger angle, you will see the NHC decrease also. Go ahead and go back and see if you can verify that. Okay, so that's it for this analysis.